Hi, do you want to know what is new in MICROSAR Classic with release R35? Well then, just stay tuned. I'm Andreas Wenkebach, Product Manager for MICROSAR Classic, and I hope you will enjoy my R35 topic selection. So let's dive into it. This is what I'm going to present. A further extension to our already extensive multi-core support. With CanSM and CanNM ready for multi-core, we close one of the last central gaps we had. Once again, a feature within our charging solution. Our new veVAS module provides value-added services according to ISO 15118 specification. Our next generation IPC offer, the new SHM component, offers a clean, robust and more user-friendly IPC solution based on shared memory. I want to recap DaVinci Configurator Classic 6, announced in my last spotlight R34. I want to share with you status and Outlook info. Central motivation for our new DaVinci Configurator Classic 6 is our new EcuC-as-Code configuration paradigm. I want to share info on what benefits you will get through this disrupting new way of configuration. And yet another announcement for our new MICROSAR bootloader that is going to be available in 2026. First of all, let me introduce our R35 CanSM and CanNM multi-core support. This new feature enables a highly distributed multi-core CAN stack. Not just COM-M, NM, and the CAN stack as before, but now also native multi-core mode and state management within our BSW split configuration. Now, you may ask yourself, what is it that makes this beneficial? Well, error-prone project-specific solutions are no longer needed. No more need to fuss with cross-partition API forwarding or handcrafted CDD logic to keep data consistent across cores. Our new release product solution is not only much less error-prone and easier to maintain, but also, from the very beginning, faster to set up. This helps to reduce your ECU project risk, especially with large ECU architectures where you have a large number of CAN channels. This happens by now managing CAN driver modes and network management across cores. This includes partial networking clusters which are now possible to design per core or per partition. This new feature fills the last relevant gap we had in our multi-core CAN story in regard to state and network management. Configuration is top-down via COM-M. You can initiate multiple CanSM and CanNM instances, as many as needed, and simply derive their setup from COM-M's channel to partition mapping. Two key rules keep things predictable. First, a channel maps to exactly one partition, and second, multiple channels can share one partition. I want to show you the idea behind with the help of this diagram. Look at core X on the left. COM-M controls channels 1 through 4. Together with the COM module, data and control path are coordinated via NM and PDUR layers respectively, down to CanNM, CanSM, and finally CAN interface and CAN driver. On the right, core Y mirrors this for channels 5 through 8. Each side operates independently and locally, which is exactly what unlocks scalability and performance. Instead of rather unclean solution where a single CanNM, CanSM representation on master core needs to be addressed by subcores, both stacks here can now operate completely independent. One practical note. This model works out of the box when each CAN channel uses its own transceiver. If a single transceiver is shared across multiple channels, additional coordination is needed. You'll find the recommended patterns and API adjustments in the multi-core user manual, our best reference to avoid cross-partition pitfalls and ensure correct transceiver handling. This user manual is important and very much recommended to walk through in order to set up your multi-core configuration right from the beginning. To summarize, native multi-core CanSM and CanNM make distributed CAN straightforward, robust and scalable, with simple COM-M-driven configuration and no more custom intercore plumbing. My next spotlight feature for you is our new veVAS module for value-added services according to ISO 15118. ISO 15118 not only standardizes the charging communication, it also enables value-added services. Services that go beyond charging and provide additional functionality. With veVAS, we introduce a new module in the charge stack that supports the services via a separate TCP IP connection, running in parallel to the charging communication. With release 35, veVAS supports a battery data exchange protocol. This protocol was introduced by the Korean government and is mandatory for electrical vehicles newly registered in Korea. It is not just a future requirement, it is already used by vehicles in the field. To integrate veVAS into customer systems, we provide a callback interface to your application, based on the same concept you may already know from charging basic software module veSCC. This interface is used to receive battery-related data and forward it into the charging station or some other electrical vehicle supply equipment, additionally to exchange control parameters such as start, stop, and error information. The veVAS module itself fully controls the TCP IP connection, including setup, monitoring, and termination. The application does not need to handle the TCP connection at all. veVAS also offers configuration options, for example, an individual message cycle time for the service. Let us have a look at the charging architecture view. veVAS is added as a new module to the existing charge stack. It runs in parallel to the classic charging communication and uses a dedicated channel for VAS communication. Today, the application still acts as an intermediary between veSCC and veVAS. And this is exactly where the Outlook comes in. A key next step is the interface between veSCC and veVAS for the ISO 15118.8 service selection process. This will allow value-added services to be automatically selected and started without involving the application as a man in the middle. As a result, application complexity is reduced and overall system usability is improved. Let me introduce to you our new shared memory-based IPC mechanism, delivered to you starting with release R35. Like with our existing solution, it enables communication between software stacks on one and the same SoC. MICROSAR Classic to Classic, MICROSAR Classic to MICROSAR Adaptive, or our products to third-party stacks. All these use cases are possible as long as they implement this SHM mechanism. It is replacing our existing IPC solution with a clean, robust, and more user-friendly solution. With this new solution, we use shared memory as the physical layer. Data is exchanged PDU-based, just like on CAN or Ethernet, only the physical layer is now shared memory. On top of this, we support both signal-based IPC and some IP-based IPC. A single message is either signal-based or some IP-based. However, both communication styles can coexist within the same stack if required. Within the software stack, messages are sent and received via IPDUM and a new SHM component. This keeps application and communication layers independent of the underlying transport mechanism. The design is hardware agnostic, allowing the same software to run on different SoC platforms. In addition, we now provide full modeling and tooling support at system level. Shared memory regions in RAM, communication endpoints, and PDUs can all be defined centrally. This represents a significant improvement over the previous Classic IPC solution, which required manual configuration. The new solution is compatible with MICROSAR Classic and designed for MICROSAR Adaptive. The adaptive implementation will follow shortly. Overall, this ASHM-based solution replaces the former IPC mechanism used in the Classic stack. In typical systems, Classic-to-Classic communication will most often be signal-based, while Classic-to-Adaptive communication will usually rely on some IP. In summary, shared memory IPC via SHM provides a high-performance, hardware-independent and well-integrated foundation for communication between software stacks on a shared SoC, with modern modeling and tooling support across Classic and Adaptive architectures. In my last spotlight video for Release 34, I announced DaVinci Configurator Classic 6 to you. Let us do a short recap today and have a look together on the current status. You may want to return to the previous R34 announcement video or our website again for more information on the general ideas. So let us start with a short recap. DaVinci Configurator Classic 6 is designed with modular architecture to meet the demands of modern software factories. It enhances both collaboration through EcuC-as-Code paradigm and both collaboration and performance through modular design and configuration caching. The rollout happens in two phases. Evolution step 1 already happened, while step 2, where the full potential will play out, is planned for Q1, Q2 2027. Now, what is the status? With Release 35, released end of last year, selected projects received the new tooling. So we get the first feedback from customers. Also, some issues need to be addressed still. With Release 36 in March, a broader range of customers will receive the new tooling, then in a more major status. Let us have a look at the migration roadmap. Hardware-independent components have been migrated with Release 35 already, while MCAL components need to be differentiated. With Release 35, we migrated CAN, Ethernet, LIN drivers, and corresponding transceiver components. MEM components are planned to be migrated until Release 36. I2C drivers are going to be migrated until Release 37 only. For each group, there can be a few exceptions. For these, we decided to wait until there is demand, if they only have been seldomly demanded in the past. If there is no native Configurator Classic 6 support yet for a given driver, we still can deliver you drivers based on Configurator Classic 5. While this comes at some performance cost, it is still possible to configure. Let us know in case you are not satisfied with the performance and we prioritize the corresponding migration task. For this reason, we also continue to provide Configurator Classic 5 with deliveries. A script checks for you if you need to use it still in addition. Check the README on the configurator contained in your delivery for more details. For example, how to get the new Configurator Classic 6 tool, which is no more coupled to a release and thus also no more part of a delivery. We still constantly work on optimizing the tool performance. Conditional generation allows components to use cached generation data, in case there are no dependencies to changed components. To model these dependencies is an additional step for the BSW components on top of the mere migration. We started this activity with focus on very central components where the potential gains matter most, already in Release 35. The performance improvement, however, will be visible only with Release 36, as caching will only be enabled with Configurator Classic 6.3 release in early March. With subsequent releases, we still enhance the scope to less central components for more performance improvements. Starting with March and then at full scale with Release 36 in April, We recommend to evaluate the new tooling based on our VTT evaluation. The basis BSW package will be offered to you free of charge via our new customer platform VHub, while the bundle, including licenses, training and support, can be purchased for a small price to cover the additions. Let me announce a real disruptive innovation, our new configuration paradigm EcuC-as-Code. The main motivation behind our new tooling architecture of DaVinci Configurator Classic 6. Let me share with you our new vision for configuration management. Our primary goal is to enable streamlined engineering cycles. EAC allows transforming configuration into an automation-ready asset. EAC ensures consistent and reproducible quality across projects and teams, reducing variability and improving reliability. By providing a developer-friendly environment aligned with modern tooling and CI/CD practices, organizations can foster collaboration and streamline workflows. Additionally, building a scalable configuration ecosystem allows for reuse and long-term stability, which is critical for complex automotive projects. These improvements collectively empower teams to innovate, positioning configuration as a strategic capability rather than a bottleneck. Next to streamlined workflow, the emphasis is on providing more transparency and sustainability. Configuration thus evolves into a cornerstone of modern software development processes. Our EAC offer to you will leverage a developer-centric workflow supported by runtime environments and IDE plugins for popular platforms like Visual Studio Code and IntelliJ, with Kotlin as initial language. Let us have a look at the illustration at the right. At its core, the solution includes an EAC foundation layer and an abstraction and workflow framework, both designed to provide stable APIs and clear extension points for customization. The process is managed through a Git-driven pipeline enabling version control, automation, and seamless integration into CI/CD systems. This pipeline follows a structured sequence, starting from ECU and diagnostic extracts, creating a derived EcuC baseline, executing code transformations, and generating enhanced EcuC configurations that feed into BSW RTE code generation. A key aspect of the approach is its pragmatic migration strategy, allowing active EcuC and EAC concepts to coexist during transition phases. This ensures minimal disruption while gradually introducing modern practices, making the adoption process smooth and risk-free. With March, a first development kit will be available within DaVinci Configurator Classic 6 first evolution step. By September, an extended development kit will allow fully featured configuration via EcuC-as-Code. 2026 is certainly the year for our new modern and robust MICROSAR Bootloader product. Over the past years, we have developed the MICROSAR Bootloader on the same architecture that powers all other MICROSAR products. For our customers, this means consistent methodology, unified workflows, high quality and reliability uniformly. The new architecture also brings several technical improvements. The new bootloader supports full interrupt handling, which is especially valuable for complex setups such as Ethernet-based projects. It also benefits from the broad availability of interrupt-based drivers, which are typically already part of our AUTOSAR-compatible driver portfolio. Every delivery of the MBL includes the dual target approach. With the dual target approach, the user can switch between virtual and hardware target platform. Virtualization enables development to commence prior to hardware availability. Configuration parameters can be validated on the virtual model, and upon migration to the physical hardware, Potential issues, such as memory mapping conflicts, can be easily identified. The architecture is fully aligned with MICROSAR Classic and HSM, so configuration synchronization becomes much easier and smoother using our existing ECU Project Sync tool feature. For the first time, all software update use cases now rely on the same unified software stack. That means no more mental switching between different update configuration concepts depending on the scenario necessary. The MBL follows a generic concept which keeps OEM variants close to each other and reduces development complexity. Because the bootloader is highly configurable, we rely on our modern EcuC-as-Code paradigm to ensure that configuration is efficient, transparent, and future-proof. Evaluation of the MICROSAR bootloader is already possible today. And after Q2 of 2026, the first production deliveries will be available. So if you're interested in evaluation, let's get in contact. Hopefully you enjoyed this latest spotlight session on MICROSAR Classic Release 35. I'm convinced you could extract at least some valuable information for you. I will be happy to see you again on the next R36 Spotlight video. Thank you for your attention.